All right, so chain rule alone was not enough. So what happens when we have a chain inside of another chain? Usually we just look for parentheses, but sometimes there's understood parentheses that we're missing. So in this particular question, we need to also understand that there are parentheses here as well. So I want you to notice that you've got one really inside function, another inside function, and then the outside function as a whole. We've got 3 different chains here. So you can use whatever letters you would like. So I'm going to use U for my inside function. So U is 2t. And then I'm going to use W for my next inside. I don't like to use V because my U's and V's look too much alike. So here I've got 5 minus sine of U. We've already replaced this with U. So 5 minus sine of U. And then my G of function, G, is cosine of, and then this whole piece we represented with W. So this is cosine of W. So what we've seen is with Newton's notation, we just find the derivative of each of these and multiply them all together. In Leibniz notation, I just want you to see because it's so cool. If we're trying to find the derivative of G with respect to t, according to this, I've got a U with respect to t, so derivative of U with respect to t. Here I've got a W with respect to U, so we would get dW with respect to U. And then here we've got a G with respect to W. So dG, dW. So the du's go away, the dw's go away, and look, you're left with dG, dt. I just think it's pretty cool. You're going to notice in my homework, I kind of get a little bit lazy, and I just kind of draw these arrows that imply I'm doing the derivative. So what is the derivative of 2t? Well, it's 2. What is the derivative of 5 minus sine of u? So the derivative of negative sine of u is negative cosine of u. And then the derivative of cosine of w is negative sine of w. So we have to multiply all 3 of these derivatives together. So this negative negative is going to become positive. So I get g prime of t equals positive 2 cosine of u sine of w. But that's not with respect to t. So we have to start plugging stuff back in. So we get cosine of, and then u was 2t, and then sine of w, and w was 5 minus sine of u, and I don't want to put another u here, so I'm going to replace the u, a double replacement. That's the derivative. Isn't it beautiful? Maybe, maybe not. So last but not least, they introduced something called the power chain rule. This works if you have a function, f of x, inside of some exponent. So if you had, for example, x plus 2 quantity to the 6th power. Nobody wants to expand the 6th power and then find the derivative. Chain rule works just fine. This is just a shortcut. You do not ever have to do it. Okay, so this one, the shortcut is if I have a function raised to the n and I want to find the derivative of that, then we're going to do a combination of the power rule and the chain rule. So our power rule says bring the exponent down and then subtract 1. The only part we have to remember is we have a function in here, so we have to multiply by the derivative of the inside, by f prime of x. So here, in number 6, it says find the slope of the line tangent to sine of x to the 5th at the point where x equals pi thirds. So you're going to see this notation a lot. What I want you to recognize is that is the same thing as sine of x to the 5th power. Those two notations mean the exact same thing. So if I'm going to use power chain rule, and I'm going to find the derivative of sine of x to the 5th power, I'm going to use that power chain rule. I'm going to bring the 5 down. So 5 sine of x to the 4th power, but then I have to remember to multiply by the derivative of the inside. So the derivative of sine is cosine. So that's the derivative, but they said at x equals pi thirds. This is when your unit circle knowledge comes in handy. Sine of pi thirds, I'm going to give you a second. So sine of pi thirds is square root of 3 over 2. And then cosine of pi thirds, now this is a great no calculator question because the square root of 3 to the 4th power is square root of 3 times square root of 3, which is 3. And then square that, you get 9 over 2 to the 4th, which is 16. So we get 5 times 9/16 times 1/2. So we get 45 over 32. Isn't it lovely? I think it's beautiful. Now, part B, same type of a thing. This one is one of those that we can rewrite. Anytime you've got 1 over something to a power, we can rewrite that as 1 minus 2x to the negative 3rd power. So for part B, I'm also going to use that power chain rule. I'm going to bring the negative 3 down. And now negative 3 minus 1 is negative 4. But then don't forget, times the derivative of the inside, which derivative there is negative 2. So negative 2 times negative 3 gives me a positive 6. And the negative exponent means put it on the bottom. So there's my derivative. Now, but this one said, show that the slope of every line tangent to this curve is positive. So I get this really yucky kind of function, but what we need to recognize is 6 is always positive. And anything raised to the 4th power is also always positive. So if I do a positive divided by a positive, therefore it will always be positive.